Hello everyone, I hope your day is going well. During my presentation, I will discuss an interactive user group recommendation system based on reinforcement learning. As you know, recommender systems help users find relevant items. In most systems, recommendations are determined by their previous behavior, but it works differently for interactive recommender systems that use reinforcement learning. Generally, reinforcement learning is a powerful framework for interactive or sequential recommender systems, and by interacting with its environment, it makes the best recommendations. Users without any knowledge of the system are called cold users. They're either new to the system or have vague requests, and these are unknown to both the system and the users. And user data and items play a critical role in the process of recommending and improving their understanding. To improve the learning process, most other systems rely on user feedback, and rating or behavior data may be used to provide them explicitly or implicitly. In interactive recommender system, user they identify their goals through interactions, and then they recommend groups. Interaction between the system and the users continue until the system has a better understanding of the user's needs. Users' behavior is unknown, and many interactions are required to discover dependencies, which damage users' experience with the system and prevent proper recommendations. And some interaction may be difficult to predict because they may contain irrelevant and noisy data. As a result, the suggested approach is to increase the accuracy of recommendation algorithms by discovering connections and semantic relationships between data and improving the quality of users' data models. In addition to user feedback, modifying the user data models implicitly affects the recommendations results and enhance their knowledge and semantic information needed for interactive search results. We can finally identify our target group by discovering the connections and semantic relationships of the datasets during model building and by analyzing and exploring the user groups. In this table, you can see how similarity was calculated. A simple neural network was used for this purpose. Pre-processing is done based on GFID scores, and then the model is trained and the vector for each word is extracted. Now we need to use method for getting the document's vector. And we use the average of keywords to create the document vector, and clustering and cousin similarity can be used for matching. In this case, the cousin similarity produces better results. An offline phase and online phase can be considered as a general solution to obtain the optimal policy. And in the offline phase, a human user simulates the process and gives feedback and recommendations, but because it's an automatic system with no time limit, it can be repeated many times with different simulations and receive rewards. And this phase, the process learning the optimal policy based on rewards and action. Now, in the online phase, a human user enters the system and performs various steps and the system's recommended action in this case. Now we need to ask what are the feedback or actions, and how can we formulate them. The feedback we receive is a set of actions that help us to find users, and the user performs different semantic actions with the system, and the user chooses groups and takes action to achieve the goals. A user may want similar groups or recommended other groups to increase the diversity of the group chosen. I will explain some of our model's actions as examples. For example, the explore around that goes around shows that what is attracted. To formulate this action, we need to consider the feedback from the user. So that Jaka's similarity with this group can be calculated. And on the other hand, since I want to get all the users, the diversity will increase. The other action is explore within, which goes into selected group and finds the desired groups and increases the overlap. The other action is by facet. By facet divides incoming groups based on one facet, for example, into males and females. So, the purpose of performing action is generally to do what the user wants with the data. In this case, we want to make that a feedback and recommendation process more intelligent. This way, the agent not only gives us a suggestion but also recommends the best action. So, in reinforcement learning, the goal is to learn the optimal policy and then recommend the best action and feedbacks. This sequence of states and action becomes a policy learning session. The user doesn't know what kind of feedback is the best provided and has a vague request and question. In this situation, the user may ask the system what action to achieve the best results. The agent with the optimal policy moves in parallel with this user, recommending the optimal answer whenever the user asks a question. So, a cooperative relationship between the user and the agent speeds up and simplifies the process of reaching the goal. Now, what kind of policy is good? When a user takes an action that moves the user closer to a goal, the system is expected to receive more rewards. In general, a reward shows how close we are to our goals, and the system will receive fewer rewards if an action moves the user away from the goal. The best policy is that maximize rewards during interactions, and the agent receives rewards when find new target users. RL is generally applied to physical environments such as robots that have specific and limited actions. But our problems are more complicated and we have more states and actions. So, if we use the same method as robots, learning will be less efficient. Therefore, instead of learning on state, learning is done on features. The idea is to describe each state with a set of characteristics. Instead of having a billion of combination of feedback, I have a specific number of features and perform learning based on them. Finally, we need to make update and we use a Q learning algorithms. To test the model, a dataset of course, jobs, and LinkedIn was used. A dataset of course comes from edX Online Education, and a dataset of jobs comes from ICCCKE job posting. And the last dataset is LinkedIn. It's also contain information on LinkedIn, the users. There are several groups in which target users are scattered and we want to collect them from each group. We calculate the utility of groups based on the true positive rate and false positive rate. True positive rate calculates target user found in target groups, while false positive rate measures non-target users found in target groups. To find the member of groups, we want to know if all the target users are into one group or if they are scattered across different groups, how that will affect agents' learning. In the figure, the y-axis indicates the average number of steps and x-axis indicates the number of simulated sessions. In the first experiment, all target users are concentrated in the same group. The second experiment, the same number of target users is gathered from two non-overlap groups. In two other experiments, we scattered targets over 4 and 10 groups in the same way. As can be seen from the diagrams, when the target users are scattered, it becomes more difficult for the agent and requires more steps to reach the goal. However, if the targets are gathered into one group, it's easier for the agent to find the targets, and simulations makes the agent smarter and help it learn a better policy. We want to check the effect of learning policies on the other type of learning in a next experiment. With this experiment, a model without data collection and a source algorithm were used to learn a policy. According to this algorithm, the current action and new reward are learned based on the current policy. So to access the utility of each policy, the percentage of a detected group member is measured. In the figure, we see that the average number of steps to find 50 and 80% of the target users decreases over time, which indicates that the agent has improved with learning. And this experiment concludes that policy learning with features is more effective when there are more target users. I would like to emphasize that interaction are very important for today's applications because over time the question of users who want to use the data becomes more ambiguous and we need to make them clear. So it's possible to achieve good results when users and AI work together and we use RL as an infrastructure to create dynamic between AI systems and users. In the end, thank you so much for your attention to me.